All right, guys. Welcome everyone to the first lesson of Form 4 Chemistry. Yeah, okay. So, um, before I start, I need to give you guys a very quick overview. Okay. So, uh, you learn science in your Form 1, Form 2, and Form 3. Okay. So when you come to your Form 4 and Form 5, the science can be further break down into three different subjects. So we have physics, we have chemistry, and we also have your biology. Yeah, biology. Yeah. So we have total three different streams of your science. Okay. So I'm doing the chemistry for you all. Yeah. All right. So there is a few things that I need you all to know in the first place. Okay. Uh, for your batch, for your batch this year Form 4, in terms of the foundation, or the basic, you guys are the weakest. What you guys are considered the one with the weakest foundation throughout the past 20 years that I'm teaching. Yeah. One of the main reason is no exam. Yeah. Previously, you never gone through the proper examination. Yeah. You didn't go through UPSR. You didn't go through PT3 exam. So that's why you guys are in a situation that you not even know. Okay. You guys are in a situation that you not even know. Okay, whether you understand or not. Yeah. So that is one of the things that you have to really focus on. Okay. Again, guys, the reason I tell you this is not to offend any one of you, but I need to tell you the truth. I need to tell you the truth. Okay. Okay. Hold on. Okay, so I need to tell you what is happening. Okay, because you might keep on listen something good. Okay, like okay, you are very good, you are very good, you know this, you know that, but that might not be the truth. Yeah, I need to know what is the situation. Okay, and then I realized that for nowadays there are three very bad combinations that can combine together and make it worse. Okay, the first one is weak foundation. Okay, so the second one is lazy. The third one is overconfident. Okay, so I find that this trend appear in many students nowadays. Okay, it make it very worse one. Okay, if your basic is weak but you are hardworking, is okay. But if you have a weak basic and you are lazy and some more you are overconfident, it's very hard. Some student cannot take in any and any criticize. Yeah, like when like just like when I say this, some of you will feel super offended one. Some of you will feel very offended one. Yeah. So if you being too confident, it's not good. Okay. If you being too confident, it's not something very good. Okay. So I want everyone try to be humble and try to learn as much as possible. So what we can do it in a better way. What we can do it in a better way is this. Okay. So when I teach the lesson, first of all, I hope you have the interaction with me. Yeah. So at least when I ask a question, like for example, I ask, do you understand or not? You can just type yes or no in the chat box. Okay. Because if you just keep quiet, I have no idea at all. Number one, whether you are here or not. Number two, whether you understand or not. Guys, I'm not magician. I couldn't read your mind. If you never interact with me, you just keep quiet. I have no idea you understand or not, and I have no idea how to help you. Number two, when I explain, if you have anything you're not sure, please ask question. Don't feel shy. Don't feel bad to ask question. Now, some student might thinking, oh, the question I asked might be too easy. Other people will laugh at me. Don't ever think like that. Please, don't ever think like that. Yeah, don't ever think like that. Okay, so anything not sure, just ask. Just ask. Okay, all right. And when you ask the question, I prefer you send the message to the public space. Okay, as in everyone can read the message. I don't like the culture of sending a private message. I don't like it, okay? Because I don't think when we are learning together, okay, I don't think it's so secretive lah. I don't think you need to text me secretly to ask the question lah. So if possible, I prefer you ask the question in a public space. Why? So that everyone can read the question, everyone can learn from there. Sometimes the question that you ask might help other students as well. Sometimes the question you ask can help other students as well. Okay. So I hope everyone actively do ask the question. Yeah, that's it. Okay. So I hope you guys are clear. I hope you guys are clear with this simple introduction because I want everyone to have a right mindset first. Because sometimes I find it doesn't make sense. Let's say I have a class which have 100 students. Okay. Of course, I know some are shy for certain reason, but it doesn't make sense if one class got 100 students, but only less than 10 students who are replying. It doesn't make sense. It doesn't make sense for me. Yeah. So I hope at least I have at least 30% of students who are replying. I hope for that. Okay, I really, really hope. Yeah, because if you keep quiet, I have no idea how to help you. And let me tell you a true story. Recently, one parent contacted me. So he asked for help. He said his child is in my class for 1 year in the Form 4, and he's now in Form 5. His Form 4 never passed. He never passed the Form 4 exam at all, not even once. Every time failed. So he asked, what can I do to help? Guys, do you think what I can do to help? I'll be honest, I cannot do anything to help. Why? Simple reason. Number one, it should be the student that asks me for help, not the parent. Yeah, if the student really care, you should come and ask me, not your parent. Yeah, I'm teaching you tuition, not your parent. That's the first one. Number two, this fella that attend my class, I don't say the name. Yeah, this fella attend my class for 1 year. No interaction at all. Never say hi, never say bye, never say thank you, never say yes, never say no. Zero interaction. You see this name appear in the participant every single week for 1 year, but never have any response at all. And after the class, never ask anything, nothing at all. So what I can do to help you guys, I couldn't help you, right? If you never come forward, you never approach me, I don't know what is your problem. I couldn't help you. Yeah. That's why I say a simple thing. Yeah. I don't care what is your situation. I cannot help with this. I cannot help with this. But if you have a weak foundation, I can definitely help you. I can help you no matter how weak you are. As long as you are not lazy and you are not overconfident, I can definitely help you. Yeah. So that's it. So I spent about 10 minutes just to give you an introduction. So everyone should have a proper mindset. Okay. And please don't be over chill in Form 4. Many students, the entire Form 4 is honeymoon. They play in the entire Form 4. Then only Form 5, they start to get serious and the time is so limited because in the Form 5, they need to learn everything in Form 4 and Form 5. 2 years need to learn in 1 year. It's very, very suffering one. Yeah. So I hope everyone don't be too chill in your Form 4. Start working hard in your Form 4, please. Okay. All right. So let's start. Okay. So today's lesson is not going to be too hard because most of the concept that we learn today is something that you already learned back in your PT3, yeah, something that you learn in your Form 1, Form 2, Form 3. So today's lesson should be a little bit more relaxed. Today's lesson is a little bit more relaxed because most of the thing we learn today, you learn back in Form 1, Form 2, Form 3. Okay, so let's start with this. Okay, in your chemistry, we have total 8 chapters. We have 8 chapters in your chemistry. Yeah, we have 8 chapters in your chemistry. Yeah, we have 8 chapters in chemistry. So chapter 1 is just a simple introduction. Chapter 1 is just a simple introduction. Chapter 1, just a very simple introduction to your chemistry, which is not being tested in your exam. So that's why for me, for the past 20 years, I would never teach chapter 1. I will skip chapter 1 because chapter 1 is very easy. You can do your own reading. And most importantly, it's just an introduction. This Chapter 1 is not important at all. So we will start with chapter 2. So chapter 2, the title of this chapter called atomic structure. So we want to know what is the structure of atom. What is the structure for atom? Okay, you all should heard about atom, right? Back in your Form 1, Form 2, and Form 3. Yeah. Okay, let's start. So first thing first, we must know what is matter. What is matter? So matter is referred to any substance. Matter is referred to anything, any substance that has mass and occupied space. So anything that got mass, anything that occupied space, we are consider them as matter. Example, is car a matter? Yes, car has mass. For example, 1,800 kilo. So it has mass. It occupied a space. It occupied certain space. So it is a matter. Let's say you and me, human. Human, are we a matter? Yes, we have mass. Yeah, maybe you are 50 kilo, I am 70 kilo, she is 35 kilo, so we have mass. And we occupy certain space in the earth, right? We occupy the space on this planet earth. So we are matter. So even something you couldn't see, for example, the air, we couldn't see the air, right? We couldn't see the air, okay? We couldn't see the air, okay? We couldn't see the air, okay? So air also has mass, right? Air is super, super light. So air has mass, okay? And then air also occupied the space bar. So in the surrounding here, we will see the air actually fill up the space. Abdul Fattah asked what is occupied. Okay, occupied means they fill up a space. They fill up a space. Okay, okay, fill up a space. All right. So Abdul Fattah, may I know, like previously you learned in English or BM, because it seems like your proficiency of English is a little bit weak. Yeah. Yeah, so guys, okay, if you're weak in language, it's a bit hard for me to help you. If you are weak in language, it's a bit hard for me to help. Yeah, all right. So now, next one, okay? Okay, so now, okay, guys, first of all, let me know in the chat box, are you okay? What is matter? Are you guys understand what do we mean by matter so far in the chat box? Yes or no? Are you guys okay with that? Very good. Okay, I like the interaction. You see, at least I can know, okay, you are okay with that. A simple interaction with me will make me happy. Yeah, a simple interaction with me will make me happy. At least I know you are following. At least I know you are following. Yeah, all right, very good, guys. That's a good thing. Okay, the second thing. All right, all the matter that we got, they are made from tiny and discrete particle. All the matter they make by tiny and discrete particle. Tiny means very, very small. So all the matter they make by something even smaller. What do we mean by discrete? Discrete means can be separated. Okay. All the matter made by something smaller which can be separated, which is called particle. Example, a house. House is made by something smaller called bricks, right? Can we separate the bricks from the house? Yes. So it is discrete. Yeah, it is discrete. Okay. So let's say we as a human, so we are made from something tiny and discrete. We are made by something smaller, which is cell, right? So our body is made out from cell. Cell is very small and cell can be separated. So all the matter is made from tiny and discrete particle. All the matter is made from tiny and discrete particle. Yeah, that's it. All right. So I hope everyone can understand this. I hope everyone can understand this thing. Yeah. Okay. Next one. So there are total 3 types of particle in chemistry. So in chemistry, starting from today, when I say particles, you must know there are 3 particles out there. And these 3 particles is nothing new. You already learned these 3 particles back in your Form 1, Form 2, and Form 3. So the 3 particles we have is called atom, molecule, as well as ion. So we have atom, molecule, and ion. So all substance is made by something smaller, which is called particle. The particle can be atom, can be molecule, or can be ion. All right. But even until today, or some students, even until Form 5, they cannot differentiate. They cannot tell the difference between atom, molecule, and ion. So I don't want that. I want you all to be very, very clear about what is atom, what is molecule, what is ion after today's lesson. All right, what is atom? Atom is referred to somebody who come alone. So when this fella come alone means no friend. When this fella come alone, they didn't combine with other people. They didn't combine with other things. This fella is an atom. Example, this carbon come alone, right? This carbon come alone. It doesn't combine with other thing. It doesn't have friend. So this carbon is an atom. This fella is Al. Al is aluminium. Al is the symbol for aluminium, which you learn in Form 1. So this aluminium, do you combine with anything? No, you didn't combine with anything. You are alone. So aluminium is an atom. So this Mg, Mg is the symbol for magnesium. Mg is the symbol for magnesium. Again, you learn this in your Form 1. So magnesium, do you combine with anything? No, right? The Mg come alone. It doesn't combine with anything. So it is an atom. So atom must be alone. They don't combine with anything. They don't have any friends. Okay, next one. What is molecule? How I know somebody is molecule or not? Molecule, I call it non-metal gang. Okay, non-metal gang is what? When you have a gang, do you think you have one people only? No, right? If you want to be a gang, you must have more than one, more than one fella, more than one people. So non-metal gang means what? When you take non-metal, join with non-metal, you will get molecule. Let's say this fella is a non-metal. This fella is another non-metal. So when non-metal join together, they become a molecule. They become a molecule. Okay, example, CO2. CO2. So CO2 is carbon dioxide. So carbon is non-metal, oxygen is non-metal. So carbon, non-metal, oxygen, non-metal. So non-metal join together. This whole thing is a molecule. So water is made from hydrogen and oxygen. Hydrogen is non-metal, oxygen is non-metal. So non-metal and non-metal join together. So this combination, the water is made by non-metal join together. So water is a molecule. All right, next one, nitrogen gas. Nitrogen gas, you have two nitrogen joined together. So nitrogen is a non-metal. This nitrogen, a non-metal joined together, you get a molecule. Okay, so some student will ask, how I know the substance is metal or non-metal? Again, you should know this since you're Form 1 and Form 2. But even you don't know, a simple way to tell is what? Look at the name. Normally, if you have metal, the name got the sounds of im. The name got the sounds of im. Example, sodium, magnesium, aluminium. Normally when you see the name got the sounds of ilm, it should be metal normally. Okay, but not to say it apply for all cases. Like iron, even though the name don't have ilm, but common sense, you all should know iron is a metal. Zinc, although the name don't have ilm, but common sense, zinc is a metal. Yeah. So sooner or later, you should know and you must know who is metal and who is non-metal. So molecule, it's non-metal and non-metal gang together. They join together. All right. So I hope everyone know what is atom and what is molecule. Okay, last one, ion. What is ion? Ion is referred to somebody which have charge. So if this fella got charged, it doesn't matter it's positive charge or negative charge. When this fella got charged, it should be an ion. Example, Na plus, this fella got charged, right? So it is an ion. Al3 plus, this fella got charged. It is an ion. O2 minus, this fella got charged. It is an ion. So ion has charge. Okay, sometimes they will purposely do something to trick you. Example, these two fella, do you see any charge out there? No, they didn't show us the charge actually. They didn't show us the charge, okay? But they are ion. Why? Okay, so ion not only got charge, ion also can be something which is metal and non-metal. So when you see metal and non-metal joined together, they are ion. Example, MgO. I didn't see any charge, right? But Mg is called magnesium. And I know normally if the name got ion, it's a metal. O is oxygen. So oxygen, is it a metal? Common sense. Oxygen should be non-metal. If you say oxygen is metal, something wrong, something quite wrong. Yeah. So metal and non-metal joined together. So this fella is an ion. Sodium chloride. So this fella is sodium. When the name got ion, it is a metal. So Cl, chlorine. So chlorine is a non-metal. The name don't have ion, right? If the name don't have ion, normally it's non-metal. So when you have a metal and non-metal joined together, this guy is an ion. Okay? So I hope everyone know up to this moment that, okay, chemical substance made by something smaller called particle. We have three types of particle in SPM, which is atom, molecule, and ion. And you guys must be able to differentiate atom, molecule, and ion. Atom is somebody who come alone, don't have friend. Molecule is non-metal and non-metal joined together. When you have non-metal and non-metal combined together, you get molecule. Ion is somebody that got charged or metal combined with non-metal. Okay? So let me know in the chat box, do you guys understand there are three types of particle and what are the differences? Are you guys okay? Okay, we have three types of particles for chemistry and how to differentiate them. Okay, so it's not very hard. Okay, so now we go on a little bit more, then we go to do some exercise. We go on a little bit more, then we will do some exercise together. Okay, all right. So here we go. Okay, ion, you have two, right? You have cation and anion. So this one pronounced as cation. Some people they read at cation, not cation. Cation. This one pronounced as anion. All right. But if you couldn't pronounce, it doesn't matter because they won't ask for pronunciation. They won't ask for pronunciation. Okay. So now, cation and anion, what it is? Okay, cation is positive ion, anion is negative ion. All right, because we know ion got charge. When you have different charges, you can be different ion. So if this fella is a positive charge ion, you call it cation. If this fella is a negative charge ion, you call it anion. A very simple way to remember is this, cation and anion. Look at the ion here and look at the letter before the word ion. So cation, the ion in front here have a letter T, right? The T looks like what? T looks like positive, right? T looks like positive. So cation is positive ion. Anion, what is the letter in front here? And N stand for negative. Okay, so hopefully everyone know, cation is positive ion, anion is negative ion. Hopefully everyone know. Okay, let's do a simple quick self-test together. Okay, I'll give you three things. The first one is C2H5OH. Second one, I'll give you it's Al2O3. The third one I'll give you is Fe. So I will let you all to try one by one to tell me what is the type of particle. What particle we have. Remember, particle means what? Are they atom? Are they molecule? Are they ion? Okay, so let's start. All right, so let's start with the first question. This fella, you think it is an atom or molecule or ion? Just type the letter. If you think atom, type A. If you think this fella is molecule, type M. If you think this guy is an ion, type I. You think this fella is an atom, molecule, or ion? Just make a wild guess. Okay, very good. I can see majority of you here answer correctly. Huh? It is a molecule. Why? Okay, first of all, can it be atom? No, atom must be somebody who is alone. Obviously, you're not alone, right? You have carbon, you have hydrogen, you have oxygen, you have so many friends, you have so many need to join together. Obviously, you are not an atom, right? Okay. So, number two, are you a molecule? Okay, molecule is non-metal gang. Huh? Do you have non-metal gang? Yeah. Carbon is non-metal. How I know? Because carbon, the name don't have ion, so it's non-metal. Hydrogen, the name don't have ion, it's non-metal. Oxygen, non-metal. Non-metal, non-metal, non-metal join together. Molecule. Okay, ion is somebody got charge. Obviously, you don't see any charges, right? Or ion is metal plus non-metal. But we didn't see any metal here, right? You can't even see any metal here. So it can't be ion. So it must be molecule. It must be molecule. Okay, I hope all good. I hope you guys are with me. All right. Okay, let's try another question, guys. The second one. Al2O3. This fella, the name called aluminium oxide. This fella, the name called aluminium oxide is the combination of aluminium and oxygen. So tell me, it is atom, molecule, or ion, guys? Tell me, you think this fella supposed to be an atom, supposed to be a molecule, or do you think this guy is an ion? Huh? What is it? What is this fella? What is this fella from your understanding? So, okay, first of all, okay, this fella cannot be atom, right? Because obviously you are not alone, right? Obviously you are not alone. So I don't think you are an atom. So are you a molecule? Molecule is non-metal and non-metal. This fella got aluminium. Aluminium. I told you before, right? If the name got ium, if the name got ium, you should be a metal. So this fella is a metal. So oxygen, common sense, oxygen bukan logam. Oxygen is a non-metal. Oxygen is a non-metal. Common sense, all right? Oxygen is non-metal. So metal and non-metal combined together, this fella is an ion. So the last one, this is quite easy. Fe, iron. Iron come alone. Iron don't have any friend. Who is it? Atom, right? This ion come alone. It doesn't combine with anything. It is an atom. Okay? So hopefully by now you all able to differentiate what is atom, what is molecule, and what is ion. It's not hard, to be honest. It's not hard, but you really, really need to understand. You really, really need to understand what is going on. And don't memorize. Many students they suffer in chemistry because they learn it in the wrong way. They keep memorize. No point. Chemistry is not all about memorizing. You need to understand. Chemistry, you really need to understand what is going on. Okay, because if you only go by memorizing, you won't get it. You won't able to get it. Okay, so let us spend some time to do some exercises together. Let us spend some time to do some exercises together. Hopefully the exercise can give you a better idea what it is. Okay, come. All right, let me show you some good quality exercise. Okay, so when you learn, okay, for my class, I won't teach you theory only. I will also go through some exercises so you know exactly how to apply the knowledge. Because many students is this, many students like this. They learn the theory, they seems that understand, but when they answer the question, they did badly. They did badly when they answer the question because they don't know how to apply whatever thing they learn. Yeah. So that's why for me, I will teach you answering technique. After I teach you theory, we will do some good quality question together. Okay, what do I mean by good quality question? Good quality question means some state paper. We will do some state paper from Pahang, paper from Selangor, and also some past year question. Those are good quality question. Don't waste your time to do reference book exercise. Don't waste your time to do textbook exercise. Not to say they are bad. but their quality might not be same as SPM. Some reference book or textbook exercises might be too easy. So if you really want to do exercises, please make sure you do the good quality one, which is your state paper or SPM past year paper. Okay, everyone, let's try to do this. First one, the first question coming out in Pahang, this question appeared in Pahang in the year of 2022. Which of the following is an example of matter? So what is matter? Anything that has mass, anything that occupied space. Anything that has mass and occupied space is matter. So let's go one by one. A, heat. Heat. Do you think heat got mass? No, right? The heat don't have mass. Like for example, when you get near to the fire, you feel hot. Why? The fire give the heat away. Do you think the heat giving out by the fire got mass? No. So it's not a matter. Number two, light. So the light, sunlight, whatever light it is, do you think the light got any mass? No. So it's not a matter. The third one, water. Water has mass or not? Yes, water has mass. Maybe 10 gram, 100 gram, 1 kilo, maybe. And water occupied the space or not? You can put the water in a cup, it occupied the space in a cup. You put the water in a bottle, it occupied the space in the bottle. It occupied spaces. So it is a matter. Fire. Fire, no mass. So not fire don't have any mass. So it is water. Okay, so let me know in the chat box, do you understand why water is the matter? Understand why water is the matter? Can, not very hard, isn't it? Not very, very hard, okay? Okay, we try another few questions. We try another few questions together. Okay, the next question is coming from Selangor. The next question coming from Selangor. Which of the following is an example of matter? So again, matter has mass and occupied space. So heat don't have any, okay? Okay. Okay, I get a question. Teacher, if fire is not a matter, what it is? Okay, fire is not a matter, then what it is? So fire is a natural phenomenon. Okay, phenomena, okay, is a phenomena. So because you can see something catch fire, it's not a matter. It's a natural phenomenon, something that happened naturally. Fire is a natural phenomenon. It's not a matter. Yeah, all right. So heat don't have any mass, so it is not a matter. Okay, air has mass or not? Yes, air is very light. Air is very, very light, but it still has mass. Air occupied the space. Yeah, air occupied the space around us, so it is a matter. Light don't have any mass, right? So it is not considered as a matter. So the best answer goes to B, the air, udara, air. Next one. Okay, this question came up in Penang. Okay, so this is element. We haven't learned it. We will come back in a short while. All right. Okay. Okay. Okay, next question. SBP 2022. SBP 2022 trial exam paper. What is the particle for neon? Okay, you will learn the formula for neon very soon. You will learn about formula for neon very soon. But for today, I will give you the formula first. Neon is Ne. So when you're given the formula for neon, you think the neon is an atom, molecule, or ion? Everyone, let me know the answer in the chat box. A, B, C. If I give you the formula for neon is Ne, do you think this fella is an ion, is an atom, or it is a molecule? What it is? So as you all can see, the neon come alone, right? The neon come alone, it don't have any charges. So when you are alone, you don't have any friend, you are atom, right? When you are alone, you don't have any friends, you should be an atom. Yeah, you are atom. All right. So that's it. So I don't think it's very hard though. Okay, next one. Okay. This question came out in Perak. This question came out in Perak. Which of the following substances exist as atom? So atom must be alone. So who is alone? If you look at the formula here, who is alone? Obviously, magnesium. Obviously magnesium, right? Magnesium is alone. Nitrogen got two people combined together, it has friends. Naphthalene got many people, right? You have 10 carbon, you have 8 hydrogen, you have so many people combined together. You are not an atom. Lead bromide, you have lead and bromine, you have more than one filler combined together. Obviously, you are not an atom. Yeah? All right. So make sure everyone know this, huh? So atom must be alone. They don't combine with anything. They don't have any friends. Done. Okay. So we are done. Yeah, we are done with the first part of today's lesson. Huh? Okay, one more. One more here. Last question, huh? Before we move on to the second part of today's lesson. So this question appeared in Pahang. This question appeared in Pahang year 2022. So before I discuss the answer with you, can you try to spend 1 minute, try to do it? All these further, I give you the name and their correspond formula. All the formula is given here. Can you try to tell me which one is the correct answer? Let's try. Come on. Guys, take your time. Try to do this for me. Which one you think is the correct answer? A, B, C, or D? Let's try. Let's try to do it. Hey guys, you all pakat to answer the same thing. Everyone answer the same thing. C. Okay, so I only see one answer only C. No other answers. No other answers. Everyone answers C. So it's either all correct or all gg.com. It's either all correct or all gg. Okay, so I only see one answer only in the chat box. C. Okay, let's check whether the final answer is it a C. Okay, let's try. So atom is somebody who come alone. So ammonia got two fella, got N and H. Obviously, you are not alone, so it's wrong. B, magnesium come alone. Maybe is the answer. Sodium come alone. No friend, you are atom. Copper sulfate got Cu, got S, got O, got many, many people combined together. You are not alone. So obviously, you are not an atom. So the answer must be either B or C, right? Okay, now let's check the another one, ion. So what is ion? Ion is somebody who got charged or somebody made from metal and non-metal. Right? It must be somebody who got charged or metal and non-metal joined together. Okay, so now let's have a look here. So we only focus on B and C because A and donkey confirm wrong already. B, mercury. This mercury, do you see any charges? No. Mercury is a metal, but are they combined with other non-metal? No, right? When you only come alone, when you don't combine with anything, you are an atom. But I'm not looking for atom, right? I want ion, so it's wrong. Lithium oxide. Lithium, the name got ium, so it's a metal. Oxide is oxygen. Oxygen is non-metal. Metal, non-metal, ion. So C is the right one. C is the proper answer. Okay, I hope everyone know how to answer this question and get the C as the final answer. All right, it's not hard. Right? So think about atom, think alone. Think about molecule, non-metal, non-metal joined together. Ion, somebody got charged, or metal joined with non-metal. So I hope everyone okay with the first part of today's lesson. The first part of today's lesson, we learn about matter. We learn about atom, molecule, and ion. Yeah, I hope everyone can follow up to this moment. Again, everyone, if during the process you have anything not sure, please don't be shy. Don't be embarrassed. Ask. Just ask the question. I am here to help you. I am here to help you, but you must ask me so that I know what I can do for you. Yeah? All right. Done. Okay, now the next thing we have to learn today is these three words: element, compound, and mixture. So now we need to learn another three more words: element, compound, and mixture. Same thing. This is nothing new. You learn this in your Form 1 as well. You learn this in your Form 1. But again, many of you here not even know this even until today. Yeah, it's okay. It's not too late. So we want to get the idea of these three fella after today lesson. After today lesson, you must be crystal clear about what is element, what is compound, and what is mixture. Okay, you need to be able to do that. You must be able to do that for me. All right. So now let's have a look. Yeah, let's have a look on it. All right. So what is element? Element is anything made from one type of atom. So anything made from one type of atom. One type of atom means one species. Anything got only one species, it is element. Example, carbon. Is it an element? You only see one species, right? You only see carbon, nothing else. So it is an element. Yeah. So let's say another one, zinc. How many species there? One, right? Only one species. So zinc is an element. All right, next one, oxygen gas. So do you think oxygen gas is an element? Yes or no? Do you think oxygen gas is an element? Yes or no? Oxygen gas, is it an element? Yes or no? Yes or no? Do you think oxygen is an element? The answer is yes. Some people will get cheated. Some people say, sir, there are two further there, there are two oxygen. So cannot be element. No, element is something that got one species. But does it mean that it must be one atom? No, right? It's not one atom, it's one species. So O2 got two oxygen combined together. But are they same species? Yeah, you are oxygen, I am oxygen. We are same species. So it doesn't matter how many furler you have, as long as all of them belong to one same species, they are element. Yeah, so many people get cheated by this. Yeah, same thing, S8. So S8, is it an element? Yes, although you have 8 furler combined together, S S S S S S S S, you have 8 furler combined together. But how many species out there? One species. All of them are S, right? All of them belong to the same species. They belong to the same family. So they are element. So don't get cheated. Got 8 furler. Cannot be element. No. Okay, element means how many species you have, not how many furler, not how many combination. Yeah. So I hope everyone know what is element. Element is anything made of one type of atom. So when you only have one type of atom, that is element. Yeah. Next one, compound. So compound is combinations of two or more elements. So when you have two or more species joined together, when you have two species or more than that, two species, three species, four species joined together, then you get compound. Example, carbon dioxide. Carbon dioxide, how many species? Two species. Carbon is one species, oxygen is one species. So when you have more than one species, this fella is a compound. Okay, this fella C2H5OH, how many species you have? Carbon is one species, hydrogen another species, oxygen another species. So not, you have three species. Why not four species? This hydrogen is the same, right? So it's counted as one species. This carbon another species, this oxygen another species. So when you have three species joined together, you are compound, isn't it? Next one, okay? Sodium chloride. So sodium chloride, is it a compound? Yeah, you have sodium, one species, chlorine, another species. So when you have two species joined together, it is a compound. Okay? So I hope everyone understand what is element and what is a compound. Just look at how many species they have. Okay, last one, mixture. What do we mean by mixture? Many students always mess up, always confuse between mixture and compound. Mixture means they only mix. They do not become something new. That is called mixture. And they can be separated easily. They can separate easily. Example, okay? If I take sand and also sugar mixed, put together, do you think sand and sugar will combine and form something new? No. After sand and sugar put together, they are still the sand and sugar. True or not? So can we separate the sand and sugar? Yes. So they are mixture. If you take green bean, put along with red bean, Do you think they will become something new like black bean? No, cannot be. Yeah, no, right? Green bean and red bean put together, still green bean and red bean. Can we separate them? Yes, we can separate them easily. So they are mixture. Understand? Let's say magnesium and oxygen combine together, you will form magnesium oxide. So magnesium oxide, is it a mixture? No, because when magnesium and oxygen join together, they form something totally new. Can we separate the magnesium and oxygen when they combine together? Cannot. So they are compound. They are not mixture. Understand? Compound means they combine together, become something new, and you cannot separate them. Mixture means you put them together, they didn't combine to become something new, and mixture can be separated very, very, very easily. So I hope everyone understood what is element, what is mixture, and what is compound. It's not very, very hard. Okay, then some student will say, sir, then I am confused now, sir. If the carbon here, what it is? So carbon, Mr. Marty, it come alone. So it is atom, right? Correct. But carbon only got one species. Can I call it an element? Yeah, no problem. No conflict, one matter not. It's okay for you to have more than one role. It's okay that you can play more than one role, right? Like for example, for me, I can have multiple roles, right? I can be your teacher. I can be a father of somebody. I can be a husband for somebody. I can also be a basketball player. I can also be, the son of somebody. True or not? No conflict. What? Who say I only can be one fella? Who say I must be teacher only? I cannot be other role. No problem, right? So carbon, it can be an atom because it's alone. Carbon also can be element because it has one species. No problem. Okay, let's say carbon dioxide. Carbon dioxide, can it be molecule? Yeah, non-metal and non-metal join together, it is molecule. No problem. Can carbon dioxide be a compound? Yeah, you have two species. When you have more than one species joined together, you are a compound. No problem. It's okay one. Because some students start to be blur already. They say carbon is atom and carbon is element. Nothing wrong, what? It's okay, what? It's okay. Yeah. So no problem with that. Okay, guys, can you please let me know in the chat box? Do you understand the difference between element, compound, and mixture? Did you all able to understand the difference between element, compound, and mixture? Okay, so let us spend some time to do some exercise, because exercises can help us better to 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 apply whatever thing we learn. Okay, everyone, come back to here. All right, here. Okay, let's start with this. Let's start with this thing. Okay. Which of the following is not an element? Not an element. Okay. So element means one species. So we are not looking for element. So we must go for something more than one species. Okay, water. Water is H2O. Is water an element? No, right? Water got H and O, two species. So water is a compound. It is not an element. And that's what we're looking for, right? We're looking for not an element. Okay, neon. Neon is Ne. So neon, how many species? One species. When you have one species, you are element. But we are not looking for element. We are looking for not an element. So oxygen, okay, oxygen, the formula is O2. In chemistry, most of the gas, they come in two. Oxygen, O2. Okay. So O2, how many species? Although you have two fella joined together, but don't get cheated, these two fella all are oxygen. When you only have one species, you are an element. But we are not looking for element, isn't it? We are not looking for element, right? So that's why we cannot choose B or C. The best answer goes to A, yeah? So I hope everyone is okay. I hope everyone is okay with this, Okay, done. Okay, next one. Which of the following substances is made up for one type of atom? Only one type of atom only. one type of atom. So this is quite easy, okay? How you know who is made from one type of atom? So one type means one species. So one species, actually, they are referred to element. Actually, the hidden question here is who is element, okay? So I'll give you their formula first. Ferrum is Fe, naphthalene is C10H8, water is H2O. All these formula no need to memorize. Okay, first of all, air. So do you think air only got one species inside? No, right? Inside the air, you have many things, right? Inside the air, you have carbon dioxide. Inside the air, you have nitrogen. In the air, you have oxygen. In the air, you have some water vapor. You have some water vapor, yeah? So air got many things mixed together. Obviously, it's not an element, right? Okay? So air should be a mixture because you have many gases mixed together, and all these gases can be separated. You can separate all these gas easily. So air is a mixture. Something we learned just now. Iron. This iron, how many species? Only one species. So when you only have one species, are you element? Absolutely. Yeah, absolutely. Naphthalene. Naphthalene got carbon and hydrogen, two different species. So you are a compound. You are not an element, right? So water got hydrogen and oxygen, two different species. So water supposed to be a compound, not an element. So the best answer is boy, iron. So I hope everyone know how to do the question. It's not very hard though. It's not very hard though. Okay, guys, now your turn to do for me. It's okay? This question came out in Terengganu, Terengganu paper. You given four chemical substance. Who is element? Who is element, everyone? Among the four answers here, who is element? Can you please let me know the answer in the chat box? Who is element? Okay, I saw a lot of good answers, guys. Awesome. Fantastic. Everyone do a good job here. It is oxygen. Yeah, because oxygen, although you have two O, but both of them belong to the same species. You only got O, right? Nothing else. So when you only have one species, you are an element. Yeah, very good. Here you have two species, compound. Here you have C and H2 species, compound. You have C and H2 species, compound. So hopefully everyone able to differentiate what is element, what is compound, and what is mixture by far. Yeah. Next one. Among four substance here, who is compound? So compound must be more than one species. Water lah. True not? Water lah. Water got H and O, two species. Okay, gold only have one species. It's an element. Air have many gases inside. We have many gases in the air, and those gases can be separated. So they are mixture. They are mixture. They only mix. Yeah, they didn't combine and become something new. So air is not a compound. Air is mixture. Okay. So carbon only have one species. It is element, but we're looking for compound, so it's wrong. Done, huh? Okay, so we are all done with the second part of today's lesson. So today's lesson, I split into few parts. So the first part is the matter, atom, molecule, and ion. Yeah, the second part is element, compound, and mixture. So we are done with the first two parts. So far, so good. I hope everyone's still okay. I hope everyone can survive up to this moment. Okay, next one. Okay, so the next thing we have to learn is called state of matter. So in chemistry, when you see the word state, S-T-A-T-E in chemistry, state in chemistry is not like Selangor, Perak, Penang, Johor. Those are the state in a country. But when you say state of matter, you are referring to, are you a solid, are you a liquid, or are you a gas? The word state in chemistry representing solid, liquid, or gas. Okay, now You already learned about solid, liquid, and gas back in your Form 1, Form 2, and Form 3, right? But there are some small difference compared to what you learned previously. The one that you learned in Form 1, Form 2, Form 3 is the basic version of it. So now when you come to SPM, when you move on to Form 4 and Form 5, you need to learn something more advanced. You will learn something more advanced. So if you use the Form 1, Form 2, Form 3 answer, in this case, you might get it wrong. Okay, first thing first, you all must know how to draw solid, liquid, and gas. Okay, so now how you draw solid back in Form 1, Form 2, Form 3. You draw like this. Okay, you get full mark. Okay, you draw like this, maybe you can get full mark already in Form 1, Form 2, Form 3. But if you draw the same answer now in SPM, zero, no mark. Why? Because in SPM, there are some requirements. When you want to draw solid, you need to draw minimum. You need to draw minimum 3 times 3. What do you mean by 3 times 3? Minimum 3 row, 3 column. So you must draw minimum 9 circle, like minimum 1, 2, 3, 1, 2, 3, 1, 2, 3. So minimum 3 circle at here, 3 circle at here. When I say minimum, can we draw more than that? Yes. Okay. Minimum is 3 times 3. More than that is okay. Number 2, if I draw 3 times 3 like this, I still get 0. Why? Because in SPM, when you want to draw solid, you must make sure the box must be fully occupied. The box must be full. But now the box still got many empty spaces, right? You still have many empty spaces in the box, which is wrong. You shouldn't have any empty spaces for solid. So you need to squeeze in more and more circle just to make sure that you have very little space in between. So this is how we draw solid for SPM. Okay. So a bit different compared to your Form 1, Form 2, Form 3. So I hope everyone know how to draw the solid. Okay, same thing. How you draw liquid in your SPM. Liquid, if you in Form 1, Form 2, Form 3, you simply draw, you get the mark, but not for SPM. SPM, if you want to draw liquid, okay, if you want to draw liquid, you must draw a small gang of 4 to 8 atoms, okay, 4 to 8 atoms in one cluster, in one gang, yeah, and you must draw a few gang, more than one gang lah, can be 2 gangs or 3 gangs, and it must be less orderly. Less orderly means that they are not so, they doesn't arrange so nicely. Okay, example, okay, liquid, liquid, here I draw one gang. The gang got about 4 to 8 atoms, one gang. So here I draw another gang. Yeah. So this is liquid. Understand? Okay. One gang, about 4 to 8 atoms. Another gang, 4 to 8 atoms. Draw a few gangs. You are liquid. You cannot draw like this. Okay. One gang and one gang. Cannot. Why? This arrangement is too beautiful. Cannot. Liquid, the arrangement is less orderly. Liquid, the arrangement not so beautiful one. If you draw so beautiful, wrong. Liquid, don't draw so beautiful. Make it a bit messy. Yeah, that's it. All right, so liquid, they are less orderly, and then they have a few gang. Every gang got 4 to 8 atoms. Yeah, I hope everyone okay so far. Okay, last one, gas. How you draw gas back in Form 1, Form 2, Form 3? Like this or not? This is how you draw gas. This is how you draw gas back in your Form 1, Form 2, Form 3. But does it mean that gas must be only one furlong? No. Who said the gas must be only one furlong? Not really. You can draw 2 furlong together. As long as they are far apart, they are still gas. Sir, gas can be 2 furlong. Of course, what? Oxygen gas, O2, right? Chlorine gas, Cl2. Nitrogen gas, N2. So gas can be 2. It's okay, what? Can we draw 3 furlong for gas? Yes. Who said the gas cannot be 3 furlong? Sir, gas can be 3 furlong. Of course, what? CO2, 1C and 2O. How many furlong? 3. You get it? So no people say that gas cannot be three furlong one. Get it? Same thing. Can it be four furlong? Yeah. Who say gas cannot be four furlong? Let's say ammonia gas. Okay, what is ammonia gas? Ammonia gas is this. If you go to toilet, you pass urine. You pass urine. You kencing lah, you pass urine. But you didn't flush the toilet. You didn't flush water. So after a few days, when you go in the toilet, you will get a very bad smell, right? You get a very smelly gas. That super, super smelly gas, when you didn't flush your toilet, is called ammonia gas. Yeah, it's ammonia gas. So ammonia is a gas. How many atoms you have? One nitrogen, three hydrogen. Total, four atoms, right? Okay, what? So please, starting in Form 4 and Form 5, don't assume gas must be one atom. No, it can be two atom, it can be three atom, it can be four atom, no problem. As long as they are far away from each other. So gas, they are far away from each other. So guys, if you are okay, how to draw your solid, liquid, and gas in SPM, can you type the letter draw in the chat box if you're okay with it? If you know exactly how to draw solid, how to draw liquid, how to draw the gas in SPM, do you mind to type in the words draw in the chat box for me so I know that you can follow? Okay, very good. So I need to give you guys some compliment. One things that I really, really like as per now is I like your interaction. I like when you reply. I really happy. Yeah, guys, I really, really happy when you guys are replying. So at least I know you are following. I know you are here. I know you are following. Yeah, very good. Okay, fantastic. Keep it up. Keep it up. I hope you can do the same thing for the next lesson and so on. Yeah, all right. Because like what I said, if everyone keep quiet, I don't know what is happening. Yeah, I have no idea whether you understand or not. Yeah, all right. So very good, done. Okay, next one. Okay, you must know how to describe the electron arrangement. So if they ask you to describe in the words, what is the arrangement for solid, what is the arrangement for liquid, and what is the arrangement for gas, what you should do. So solid, they are closely packed. Closely packed means they squeeze together. So they squeeze together with very minimal space in between. Can you see? Very little space in between. So they squeeze together. We call them closely packed. And solid has a very beautiful arrangement. It's very, very orderly, very beautiful, very predictable arrangement. So we call it orderly. So if the question asks, describe the arrangement of solid. So you can write in solid, okay, particles are closely packed and orderly. So in solid, the particles, they are closely packed and they are orderly. Okay, liquid. Liquid is less closely packed and less orderly. So can you see the liquid, they still squeeze together, right? But they have some space in between. So they are not so closely packed. Closely packed means they squeeze together. If everything squeezed together, you should have no space, right? Liquid have some smaller space in between. So they are less closely packed. And liquid, do you see the arrangement very organized? Do you see the arrangement very beautiful? No, right? The arrangement not so beautiful compared to the solid. So less orderly. Can you write not orderly? Cannot. Not orderly and less orderly is totally different. Less orderly and not orderly is totally different. Not orderly means you cannot see any pattern. Liquid still have some pattern lah. It's just that the pattern not so good compared to solid. So make sure you know you use a proper words, less orderly. Don't write not orderly. Sometimes the use of wrong words represent a wrong meaning, you know. For example, guys, if today I scold you, today I try to scold you. First option, you want me to say you are less useful, or you want me to say you are useless? Which one you prefer? Which one you prefer? If today I scold you, which one you prefer? You are less useful or you are useless? Which one you prefer? Should be number one, right or not? Because this one sounds super offensive, right? This one sounds very bad. This one sounds very, very offensive. Wow, you are useless. Understand? Very bad. This is very, very bad. So you are less useful, not so bad. True, not so bad. See that? Okay. So different meaning, different meaning. That's why, okay, less orderly and disorder, totally different. Less orderly and disorder, or we call not orderly, totally different. So you have to use the word less orderly. You cannot write disorder. You cannot write not orderly. Understand? Use a proper keyword. Okay, next one. Gas. Gas, they are very far apart. Can you see that? They have far distance. And then gas cannot see a very beautiful pattern, right? You can write the word random. So gas, they are random and they are far apart. Yeah. So make sure everyone able to describe, okay, the arrangement of the solid, liquid, and gas. Okay, next one. So you also learn about this back in your Form 1, Form 2, Form 3, the kinetic energy. So solid, they have very low energy. Solid, the energy very, very low. Gas, the energy very, very high. Liquid, the energy is moderate. Moderate means medium lah, not too high, not too low. Okay, solid has very little energy. So gas has a lot of energy. Liquid in the middle, moderate. Okay, next one, force of attraction. So force of attraction, how you know? Force means are they sticking together? So solid, many things sticking together, the force is very strong. Liquid, something sticking together, something doesn't. So the force is moderate. Gas, only a few people stick together, not much. So only a few of them stick together. Most of them, they don't stick. So the force should be very weak. So that is a simple way for you to memorize. You go to see, are they sticking together? If they're sticking together, they have a strong force. If they're not sticking together, they have a weak forces. Yeah, that's all. Okay, the last one I would like to talk about is the movement. Okay, now, if you are in Form 2, you only learn this. Solid can vibrate at its own position. Isn't it? You learn this? Liquid can move freely. Yeah? Gas can move freely. This is what you guys learn. Yeah, this is what you guys learn in Form 2. Nothing wrong. Nothing wrong. But you cannot use this concept for SPM. Okay, why? In SPM, I need to tell you something more. In SPM, you need to look at three types of movement. When you look at movement, I want you to look at three different things. First one, vibrate. Second one, rotate. Third one, move freely. Okay, so we have three types of movement actually for your particle. Okay, now no need to memorize, just imagine. Everyone, solid. So solid, what kind of movement we have? So this is solid. Okay, so common sense. I need some imagination here, everyone. Solid. Do you think solid can vibrate? Yes. Do you think solid can rotate? Yes. Do you think solid can move freely? No. When you want to move, stuck, stuck. So you have no space of moving, right? Solid, everything squeezed together. You have no space of moving. So solid can vibrate, can rotate, but cannot move freely. Understand? Yeah? Okay, let's go for another fella, liquid. So if you are liquid, okay, if today you are liquid, so 1 minute revision, guys, liquid is what? A smaller gang of 4 to 8 atoms together, and you have multiple gang, right? Okay, so common sense. Do you think the liquid here can vibrate? Yes. Do you think the liquid here can rotate? Absolutely. Do you think the liquid can move? Yeah, you have some empty space, right? You have some empty space. So the liquid can move here, can move here, can move here. Understand? So liquid can have all movement. Yeah, they can vibrate, they can rotate, they can move freely. Okay, last one, gas. So gas, you know lah. Gas, you all should know lah. So gas, can they vibrate? Of course. Can they rotate? For sure. Can they move freely? Yeah, they can move freely like crazy because they have so many space in between the gases. They can move here and there. They can move very, very far away. Okay, so I hope everyone know about the movement of the particle. So can you see, do you learn this back in form 1, form 2, form 3? Yes. But is it the same as SPM? No. In SPM, we learn everything more detailed. In SPM, we learn everything more detailed. So I hope everyone understood what is happening. I hope everyone understood what is happening. Okay. So guys, do you mind to let me know in the chat box? Are you okay with what is happening on this page? Are you okay? What is happening on this page? So what I am trying to tell you guys is this. You learn about solid, you learn about liquid, you learn about gas in Form 1, Form 2, and Form 3. But when you are in Form 4 and Form 5, when you are in SPM, we will go more and more detail. Example, you never learn about rotate, right? Back in Form 1, Form 2, Form 3. Now you need to know there is rotation. Understand? And in Form 1, Form 2, Form 3, they are not so strict, they are not so particular on how you draw the solid, liquid, and gas. But now you can see in SPM, they have certain rules for you to draw the solid. They have certain rules for you to draw the liquid. They have certain rules for you to draw the gas. Done, huh? All right. So same thing. Let's take a break to do some exercises. Then only we move on. Yeah. All right. Let's take a break to do some exercise. Then only we move on again. Yeah. All right. So let's do this. So let's do one subjective question. So previously, all the questions that we have done, they are objective. So now let's do one subjective question. So this question came out in para. This question came out in para year 2022. So you given 4 chemical substance. This is their name. And this is their formula. You given a name and formula for 4 different chemical substances. Yeah. Next one. Based on the table, can you tell me what is the particle for tetrachloromethane? So tetrachloromethane is here, and this is the formula. So when they ask me particle, we know it might be an atom, it might be a molecule, it might be an ion, right? Particle must be atom, molecule, or ion. So guys, make a wild guess. Tetrachloromethane, this fella, is an atom, molecule, or ion. Tetrachloromethane. It is atom, molecule, or ion. Let me know in the chat box. You think tetrachloromethane is an atom, it is molecule, or it is an ion? So tetrachloromethane, what is it? What is tetrachloromethane? So tetrachloromethane is supposed to be molecule. True or not? Why? Because tetrachloromethane is made from carbon. Carbon is non-metal. It is made from chlorine, non-metal, right? When non-metal and non-metal join together, when non-metal and non-metal join together, you are molecule. Am I right? That's all. Yeah. Next one. We need to classify all the substances here into element and compound. We must know who is element and who is compound. Who is element and who is compound? So quite easy. Element means one species, compound more than one species. So as you all can see, iodine, the formula is I2. You only see I, only one species, so it is element, isn't it? All right. Copper sulfate, you have CO, you have S, you have O. You have 3 different species. So you should be a compound, isn't it? Right, next one, aluminium. Aluminium only got one species, right? Aluminium only have one species, so it has to be an element. All right, next one, tetrachloromethane. You have carbon and chlorine, 2 different species. So 2 different species has to be a compound. Understand? Okay. So I don't think this question is very hard, isn't it? Okay. So we should able to classify elements and compound easily. Yeah. So if you can do this whole question, you get yourself 3 marks easily. Yeah. It's very doable. It's quite easy. Yeah. Done. Okay. So now we are all done with the with the exercise. Okay, now let's move on a little bit more. We have two more parts to learn today. We have two more concepts to learn for today. Then we are all done for this lesson. Okay, the next concept that I want you all to learn is called the change in the state of matter. Okay, state of matter means solid, liquid, and gas. So we know solid can change to liquid, liquid can change to gas, and so on. Yeah. So this is one thing that you learned previously, again, back in your lower secondary. Lower secondary means form 1, form 2, form 3. So we have solid, okay? We have liquid, okay? All right. And we have gas. All right. So now a quick recap here, a quick revision what you learned back in your lower secondary. Okay. Now, solid change to liquid. What is the name of the process? So we learned this back in lower secondary. Solid change to liquid, it's melting, isn't it? It's melting. Okay. Liquid change to gas. Okay, liquid change to gas got two possible names. The first one called boiling. The second one called evaporation. Okay, guys, do you all know the difference between boiling and evaporation? Do you all know the difference between boiling and evaporation? Do you know boiling and evaporation? What is the difference? Yes or no? Do you all know the difference between boiling and evaporation? Okay. Okay, many of you say yes. Okay, since you say yes, can you tell me the two differences between boiling and evaporation? Can you guys tell me there are two differences between boiling and evaporation? Can you tell me that? Can anyone tell me what are the two differences between boiling and evaporation? What are the two differences between boiling and evaporation? What is it? Come on, everyone. Tell me. What are the two difference between boiling and evaporation? Hey guys, so many of you say yes just now. No answer. What are the two differences between boiling and evaporation? Come on, let me know. What are the two difference between boiling and evaporation? What is it? How you know this process is boiling or how you know this process is evaporation? Come on, just try everyone. It's okay that you answer wrongly. It doesn't matter. Just try. Just try. Okay. Okay, I see a very good answers. Okay, I see a good answers here. Okay, the first, so far, the best answer I have seen now is from Zhen Yu, Zhen Yu. Okay, so far, the first one, all right, but no one able to answer the second difference, Okay, everyone, let me tell you here. Come on, look at here, please. Boiling only occur at boiling point. Boiling only occur at boiling point. Some of you say boiling happen at 100 degrees Celsius. Wrong. Only water boil at 100. What about other substance? Let's say we have oil. Do you think oil boil at 100? No. So boiling occur at boiling point, not necessarily 100 degrees Celsius. Boiling occur at boiling point. Evaporation happen at any temperature. Evaporation can take place at any temperature. Let's say this is a liquid. It can evaporate at 5 degrees Celsius. It can evaporate at 50 degrees Celsius. It can evaporate at 70 degrees Celsius. So evaporation can happen at any temperature. Understand? Number two, okay, boiling take place in the whole liquid, the entire liquid boil. That's why when you heat up the water, where you see the bubble, the whole thing, right? You didn't see the bubble on the left, you didn't see the bubble on the right, you didn't see the bubble on the top, you didn't see the bubble at the bottom. You see bubble everywhere. So boiling happen in the entire liquid. Evaporation only happen at on the surface. Evaporation happen right on the surface of your liquid. Okay. So I hope everyone know what is the difference between boiling and evaporation. It's something that you learn in Form 2. You learn this thing in Form 2, the difference between boiling as well as evaporation. So guys, let me know in the chat box, are you okay by now? What is the difference between boiling and evaporation? Okay, so make sure everyone know this, okay. So I saw some of you here write the word speed. It has nothing to do with speed. So if you write boiling is fast, evaporation is slow, no mark. They don't accept the answer. Yeah, there are only two answers they accept. This one, okay. Boiling happen at boiling point. Evaporation happen at any temperature. Boiling happen in the entire liquid. Evaporation happen on the surface of the liquid. Yeah, so make sure everyone know what is the difference between boiling and evaporation. Okay, so boiling and evaporation both change the liquid to gas. Okay, let's go the other way around. Okay, gas convert to liquid. This process called condensation. Yeah, liquid convert to get to solid. This process called freezing. So hope everyone understand what is going on. Okay, next one. Solid change to gas. This process is called sublimation. So some of the solid, when you heat it, the solid directly become gas without going through the liquid. So it's called sublimation. Okay, guys, what is the name of the process when gas change to solid directly? Same thing you learned before. Anyone can remember? What is the name of the process when the gas change directly to the solid without going through the liquid? Anyone remember what's the name of the process? What is the name of the process when gas directly becomes solid? It's called deposition. It's called deposition. Deposition convert the gas directly to solid. So make sure everyone know this process. Okay. So then you should know all the red color here means this process need to be heated. You need to heat the substance. All the blue color here means this process need to cool down. Okay, need to cool down. I teach you a very simple way to memorize. You don't need to purposely memorize which one need to heat and which one need to cool down. Very easy one. I teach you a very simple way. You just imagine this. When you want to break up, when you want to break something, when you want to break something, you need to absorb the heat. You need to absorb energy so that they can break up. When you want them to stick together, when you want them to stick together or join together, you want to release the heat. So just remember this will do. If the process need to break them apart, the process need to absorb the heat. If the process want to join things together, they need to release the heat. Example, if I want to convert solid to liquid, look at the picture. Are we sticking them together or are we breaking them apart? Breaking, right? Solid sticking together. You want to break it to become liquid. So when you want to break them apart, absorb or release heat? Absorb. Understand? Same thing. Today, if I have gas, I want to make it become solid. Gas to solid. Initially, the gas, they are far apart. Now they need to stick together to form solid. Sticking together, they absorb or they release the heat. Release. Understand? So no need to purposely memorize one. Use common sense. Ask yourself, are they breaking apart or are they sticking together? Then you will be able to know whether you need to absorb or release the heat. Okay, that's a simple tricks you all can use. Okay, let's do some exercises. Let's do some exercise together. All right, let's look at it. Okay. All right. This question came out in SPP 2022. So the question said, Mr. Aaron found that a dry ice in a box of ice cream changed into film. Film means smoke, the gas. So dry ice is solid and then directly change to the film. Film is the gas. So what is the energy change and what is the process? So we know solid directly become gas. The name is called sublimation, right? The name is called sublimation. How you know they absorb the heat or release the heat? Common sense. Solid is like this. Gas is like this. True or not? So when you want to change solid to gas, what you do? You need to break them apart, right? You need to break them apart. So when you're breaking something, you absorb or release the heat. Absorb, right? I told you just now, when you break something apart, you absorb the heat. When you stick them together, release the heat. So absorb. So the answer is B. Do you all understand what is the simple technique I use to solve this question? Do you understand? What is the simple technique I use to solve this question? Yes or no? So you see, I don't need to memorize, right, who absorb or who release heat. I just ask myself, are they breaking apart or are they sticking together? Okay, okay, get the question, how dry ice is made? Dry ice is made from carbon dioxide. When you cool down the carbon dioxide, they will become solid. Dry ice actually is solid carbon dioxide. The dry ice actually is solid carbon dioxide. You take the solid, you take carbon dioxide, you cool it down and form a solid. That solid is the dry ice already. Yeah? Okay. Next one. Here we go. Here we go. Okay. This question came out in Kelantan. This question came out in Kelantan. So they say diagram 2 shows the formation of water droplet on the outer wall of the glass containing a cold drink. Okay, so what is this process and what is the energy change? So you all should learn this not in Form 1, not in Form 2, not in Form 3. You learn this back in your primary school. So you know when a cup got ice, it is very cold, right? So when you have certain air touching the cold surface, when you touch the cold surface, the air will change from gas to liquid. That's why you saw some liquid droplets on the glass. And this process to change the gas to liquid is called condensation, isn't it? So how you know you absorb or release the heat? Common sense. Condensation change the gas to become liquid. So when gas wanted to be liquid, what they do? They need to stick together. As what we learned today, when you sticking something together, absorb or release the heat. Everyone, absorb or release. When I want something sticking together, when we want something sticking together, absorb the heat or release the heat. Absorb or release. When you want something sticking together, release, isn't it? So the best answer is donkey. You get it? Very easy one. Very, very easy. Yeah? Common sense. Just use common sense. Okay, next one. This question came out in Kedah. This question appeared in Kedah, year 2022. The diagram below shows the process X. What is true about process X? First of all, do we know what is this process? You are given something far apart, which is gas, something sticking together, solid. So gas to solid, this is a deposition process, right? This is supposed to be a deposition process. So which one is true? A, this process is sublimation. No, it is deposition, not sublimation. B, the force of attraction becomes stronger. Okay, we learned early on today how you know the force is strong or weak. Look at whether they stick together. So initially, are they sticking together? No, the force is weak. Now they are sticking together. They are strong. So from weak becomes strong. So the force getting stronger, isn't it? The force actually getting stronger now, which is true. C, the heat is absorbed. How you know you absorb the heat or release the heat? Look at here. Gas becomes solid. They need to stick together. So sticking together, release the heat, right? Sticking together, release the heat. But they say absorb the heat. Doesn't make sense. So the best answer is B. Okay, I hope everyone know how I tackle the question. I hope you can see what is the technique, what is the skill that I use to tackle this question. Yeah. Next one. Okay, next one. What is the name for this process? This is gas. This is solid. Gas to solid deposition, right? Next one. Which of the following process involve release energy? So release means they must stick together. So which process actually makes something sticking together? Let me know the answer in the chat box, A, B, C, D. Which process you think they will release energy on? So condensation, right? True or not? Condensation change the gas to liquid. So the gas, initially, they are far apart, right? Now they need to stick together to form liquid. So remember, release energy, stick together. Okay, absorb energy, breaking apart. So this is a simple tricks that can really, really help you a lot if you understand what is going on. Huh? All right, done. Next one. What is the name of this process? This question comes from Selangor. This is very easy. This picture obviously is a solid. This picture obviously is a gas, right? Sorry, liquid. Sorry, my bad. Liquid, solid change to liquid, isn't it? Solid change to liquid, melting. True or not? Melting, lah. All right. So I don't think it's very hard. Okay. So next one. This question came out in police. This question came out in police. Which of the following processes the physical change from liquid to gas? So as what we learned moment ago, liquid become gas got two different processes. It can be boiling, it can be evaporation. Understand? Boiling and evaporation, both processes convert the liquid to gas, but they are different. Why? Boiling need to happen at boiling point. Evaporation happen at any temperature. Boiling happen in the entire liquid. Evaporation only happen at the surface. But anyway, boiling and evaporation, both processes can convert the liquid to gas. So the answer is 1 and 3, isn't it? Okay, next one. Okay, done. So I hope everyone okay. I hope everyone so far okay with the change of states. All right. So that's all. Okay. So make sure you know the name of the process lah. Melting, boiling, evaporation, freezing, condensation, sublimation, and deposition. Make sure you know that. And make sure you know which process need to absorb the heat, which process need to release the heat. You don't need to memorize, just use common sense. If the process need to break something apart, absorb the heat. If the process want to make something sticking together, release the heat. That's it. Okay? So one more extra knowledge. During the change of state, during the change of state, when you change from solid to liquid, liquid to gas, gas to liquid, gas to solid, whatever it is, when you change the state, the mass doesn't change. Make sense lah? Let's say we have 1 kilogram of solid, you heat it, you should get 1 kilo of liquid. True or not? You won't get 0.9 kilo of the liquid. You are not getting 1.5 kilo of the liquid. No way, right? 1 kilogram of solid should become 1 kilogram of liquid. If you heat 1 kilogram of liquid, you should get 1 kilogram of gas. The mass will never change during the process. Yeah. So that's it. Okay. So let me know in the chat box, are you guys okay with change in the state of matter so far? Okay. Yeah, I hope all is good. Okay, next one. All right, one more extra knowledge is here. In SPM, you need to know there are total 4 substances. In SPM, you need to understand there are 4 filler. There are 4 substances which can undergo sublimation. These 4 filler, if they are solid, you heat it, they will directly become gas. They will directly become gas. They will directly become gas. Okay. So these are the 4 filler. Okay, get a question in the chat box. Okay, Zoe is asking, sir, why people say the mass change when evaporation happen? Simple. Why when evaporation happen, the people say the mass changes? Of course, what? Evaporation, let's say this is a liquid. This liquid is 1 kilo. Okay. So evaporation happen at room temperature. It happen at any temperature. So during evaporation, only the surface liquid become gas. So only some liquid become gas. Do you think all the 1 kilogram liquid all become 1 kilogram gas? No, right? So maybe out of 1 kilogram of liquid, only the surface, only 100 gram become gas. So do you think the mass will change? Yes. True or not? Common sense, right? Common sense, right? Okay. Are you okay with this, Joey? Did I answer your question, Joey? Did I answer your question? Okay, because during evaporation, not all the liquid become gases. So when only a small part of liquid at the surface become gases, that's why not all the liquid become the gases. That's why the mass got changed. But if you do boiling, all the liquid boil to become all gases. So that's why the mass is the same. So the mass will be the same when all solid become all liquid become all gases. The key word is all. Yeah, evaporation, not all the liquid will become gases. Yeah, all right, that's all. Okay, these are 4 chemical substances that undergo sublimation. Normally, this question will ask in objective. Normally, they will ask this in objective. They will ask you who can do sublimation. So we have dry ice. So dry ice is actually solid carbon dioxide. So the dry ice that you can see in the on the stage, like on the stage, you see K-pop, they got some smoke coming from behind. That those kind of smoke, those type of fumes is actually dry ice. Dry ice is made from carbon dioxide in a solid form. Yeah. So then we have iodine. Iodine also can undergo sublimation. Okay. So then we have ammonium chloride. Ammonium chloride also undergoes sublimation. The last one is called naphthalene. So naphthalene also undergo sublimation. Okay. So what is naphthalene? Naphthalene is the mothball. I'm not sure you know what is mothball or not. Mothball is a white color ball you put in the cupboard to get rid of cockroach. Let's say there are some cockroach, you can put a white color ball to get rid of the cockroach. This white color ball, they will release some gas. This smell, cockroach don't like it. That's why they can get rid of cockroach. Yeah. So there are total 4 substances that can undergo sublimation. And the question normally is super straightforward. The question is super duper straightforward like this. The question is very, very straightforward, just like this. Example. Example. The question look like this. Okay. All right. This question came out in Pahang. This question came out in Pahang, year 2022. So they say the diagram show the arrangement of the particle when you undergo the change. So what is this process? This is a solid. This one obviously is the gas. Solid to gas, even though they never say, I know is sublimation, right? So which following substance can undergo process Y? So who can undergo sublimation? We learned just now. Who can undergo sublimation? 4 fella. Who are the 4 fella? Iodine and naphthalene, isn't it? Iodine and naphthalene. So 2 and 4. Understand? So the question very straightforward. You know, then you know. You don't know, then you don't know. Understand? Very, very straightforward. Yeah. So make sure you know who are the 4 fella that can undergo sublimation. Same thing, see? Solid change to gas. Sublimation. Iodine, naphthalene. Okay? So that's it. So I hope everyone know who are the 4 fella that can undergo sublimation. Okay? So this will be the second last part for today already. Yeah, almost done. Okay, so guys, let me know in the chat box. Are you okay? Who can undergo sublimation? Are you guys okay? Which chemical substance can undergo sublimation? Which chemical substance they can undergo sublimation? Are you guys okay with that? Not too bad lah, not too hard. Okay, if you're having problem in memorizing, I teach you a simple way to memorize. Take a piece of paper, copy these 4 names one time in a day. One time, don't copy 10 times. Don't copy 20 times. Just one time in a day. At most, it will use 5 minutes. At most, it will take 5 minutes of your daytime. Okay? So do this continuously for 1 to 2 weeks. After 1 to 2 weeks, you will see that this whole thing all in sudden stick in your brain. This whole thing will just go in your brain. This is how you memorize it. We call subconscious memorizing. Because do you have this experience? For example, let's say some of you here love K-pop. You love K-pop. You cannot read the Korean language, right? You cannot write in Korean language, but somehow you can sing the Korean song perfectly. Why? Why you can sing Korean song even though you don't know how to read, how to speak Korean language? Because of this. Because when I love K-pop, for example, I will always sing along, right? You always sing along with the song. I sing like la 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 la, for example. When you keep on singing, 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 when you keep on repeating, 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 you not even need to memorize. The whole thing will just go into your brain automatically. Understand? So if you are a person who are very weak in memorizing, try this method. Just copy. It is super powerful, super effective. Just copy only. And I didn't ask you to copy 20 times, right? I didn't ask you to copy for 1 year, isn't it? Just copy 1 to 2 weeks. You will be able to memorize this for a long, long time. Seriously. You will be able to memorize this for a very, very long time. Yeah? So if you are weak in memorizing, probably you can try this method. Yeah, you can try this method. Okay? I always challenge my student. I say, if you really follow my method, if you really copy for 2 weeks, you cannot memorize at all, come to me. Come to me. I will treat you whatever thing you want to eat or drink. I will treat you any food or drink. Come to me. Just say, sir, Mr. Martin, I follow your method, but I cannot memorize. Whatever food, whatever drink you want, I belanja you. But you need to be fair to me lah. You cannot say, Mr. Martin, belanja me. Because I use your method, I couldn't memorize. Then I will ask, how many times you copy? I copy 2 times. Cannot lah. You copy 2 times, that is not what I teach you not. I ask you to copy 1 time in a day for 1 to 2 weeks. If you really follow my advice, you couldn't memorize, come to me. I will really, really belanja you whatever thing you want. Yeah. So that is how confident I am. Yeah. So you just need to copy. Okay. That's all. All right. Done. Okay. Last thing. Last thing for today. Oh, the time's almost up already. Guys, do you mind if I spend another extra 5 minutes to teach you the last part for today's lesson? Is it okay? Is it okay if I spend another extra 5 minutes to teach you one more concept for today? Do you okay with that? 5 minutes. Give me about 5 to 6 minutes. Okay? So come, let's do it. Okay. Sometime in SPM, the question will do this. The question will give us the melting point. The question will give us the boiling point. They will give us, and they ask us to predict the state. They ask you to predict it is a solid, it is a liquid, or it is a gas. They will ask you to predict solid, liquid, or gas when they give you melting point, boiling point. Okay, what do I mean? What do I mean? I will use 2 examples for demonstration. I will use 2 examples for demonstration. Okay, let's say the first question is like this. Substance X, I don't know what it is, but they just tell me this fella called substance X. The melting point is 32. The boiling point is 79. They ask you what is the state. State means solid, liquid, or gas. What is the state of substance X at 42? So they want to know at 42 degrees Celsius, substance X is a solid, is a liquid, or is a gas. I teach you a simple method to do it, a simple shortcut to do this type of question. Now we call 3 lines method. 3 lines method. So what you need to do is draw 3 lines. So the first line is horizontal. The second line and third line is vertical. So you draw 1 horizontal line and 2 vertical line. So you will be able to see there are 2 intersections here, right? There are 2 cross here. So the first intersection here is your melting point. The second intersection here is boiling point. The sequence cannot be wrong, huh? Must be melting, then only boiling. Common sense, right? You cannot say, I want the chemical substance to boil, then only melt. It doesn't make sense, right? Must be melt, then only boil, isn't it? So what is your melting point? 32. What is your boiling point? 79, isn't it? So this box is solid. This box is liquid. This box is gas. So now ask yourself, what is the temperature we wanted? 42. So common sense, where is 42? 42, where are you? 42 should be in the middle of 32 and 79. No, not 42 should be in the middle of 32 and 79. So 42 is here. So you are a liquid. So now I know already substance X is a liquid at 42 degrees Celsius. Do you understand how three-line methods works? Do you understand how three-line method works? Okay, it's not very hard. It's not very hard. Okay? Okay, let's try one more example. Let's try one last example. Let's try one last example. Okay. Now, okay, this question is not hard, but it's a little bit more tricky. Substance Z, just now we have substance X, now we have substance Z. Substance Z, the melting point, it is negative 20. So the boiling point is 20 degrees Celsius. What is the state of the Z at room temperature? Now, they purposely don't tell us the temperature. Now, they purposely don't tell us what temperature they want. They just mention room temperature. So I want all of you here today, okay, including those of you who watch this recording afterwards, I want you all to know in chemistry, room temperature always referring to 25. In chemistry, room temperature is 25, not 26, not 37, not 20, 25. In chemistry, the room temperature always 25. And don't think too much. Why I say don't think too much? Some people say, Mr. Martin, my room don't have aircon, so very hot is 30. Some student will say, Mr. Martin, my country got snow, winter, very cold. My room is 10 degrees Celsius. Don't think so much, everyone. I don't care where is your room. I don't care which country you are in. I don't care your room got aircon, got fan or not. In chemistry, room temperature is 25. That's all. In chemistry, room temperature is 25. Understand? Okay? So now, what to do? So we can use three-line method. 1, 2, 3. So the first intersection is melting point, which is negative 12, right? The second intersection is boiling point, which is 20. This is solid, this is liquid, this is gas. So we want room temperature, which is 25. So ladies and gentlemen, where is 25? 25 is more than 20, right? This is 20, 25 is more than it. So it's in this box. It is a gas. So now you should know substance Z is a gas at room temperature. I hope everyone know what is going on. So far, so good. I hope everyone so far, so good can understand what is going on. Yeah. So we will do two questions. I do one, you do one. Is okay? I do one question, you do one question, then we are all done for tonight. Is okay? I do one, you do one. Okay, let me do one question with you. Let me do one question with you. Okay, this question I will do for you first. The first question that I will discuss with you is here. This question appeared in Kelantan. This question appeared in Kelantan 2022. They asked, which substance is a gas at room temperature, which is 25? So who is gas? We can use three-line method. So substance P, melting point 80, boiling point 120, solid, liquid, gas. So 25 degrees Celsius, where is it? 25 degrees Celsius is less than 80. So it's on the left-hand side. What is it? Solid. So you are solid. Are we looking for solid? No. So answer P is wrong. So answer P is wrong. So 1 is out. So 1 is out. 1 is out. See that? So if you look at answer C and donkey, you can see 2 and 4, 3 and 4. So I am very sure number 4 confirm correct, right? I not even need to do. I know number 4 confirm correct already. So I only need to check number 2 or number 3. Yeah. So number 2 is substance Q. Let's check substance Q. Substance Q, melting point 50, boiling point 95, solid, liquid, gas. So the temperature that we're looking for is what? Room temperature. Room temperature is 25, right? Where are you? 25 is lesser than 50, right? 25 is lesser than 50. So you are solid. Are we looking for solid? No, we want a gas. So Q is wrong. So Q is answer number 2. Answer number 2 is wrong. The answer has to be donkey. So can you see, I not even need to check everything. I know the answer already. So when you do objective question, you can use elimination method. Elimination means what? Throw away all the wrong answer. So you can do it quite fast one. Let me know in the chat box, do you understand how I answer this question and how I get donkey as my final answer? Do you okay with it? It's not very hard, huh? It's not very hard, isn't it, guys? Okay, now, guys, your turn. It's time to show your power. It's time to show your capability for me, yeah? This is the question, okay? This is the question. This question appeared in Putrajaya year 2022. Can you use 3-line methods and tell me among 4 substance WXYZ, which further is a liquid at 100 degrees Celsius? The final answer is A, B, C, or D. Come on, let's try this and let me know the answer in the chat box. Which further is a liquid at 100 degrees Celsius? A, B, C, or D? Okay, good, awesome, awesome, fantastic. I can see you guys really get the idea. It's C, why? So substance Y, it's 80 and 196, solid, liquid, and gas. The 100 is in the middle. So it is a liquid, yeah? So again, some of you might do very fast, some of you might do a bit slower. It doesn't matter. It doesn't matter. Do remember, do understand that everyone have different learning capability. Some very fast, some a bit slow. It's okay one. Learn at your own speed. Learn at your own pace. Yeah, learn in a pace that you feel comfortable. Then you'll be fine. Okay, sorry, one more. One last question. Now, last question for tonight. Let's do this. So you given 4 furlor PQRS, you given 4 furlor PQRS, who is a liquid at room temperature? Let's try this. Let's try this. You given 4 furlor now, P, Q, R, and S. Who is liquid at room temperature? The answer is A or B or C or D. Come on, let's try this. Who is liquid? Who is liquid at room temperature? Who is liquid at room temperature? Okay, I saw 2 types of answer in the chat box, which is A or C, which is A or C. Okay, so let's double check what is it, A or C. Okay, so substance P, negative 75 and negative 15, solid, liquid, gas. Room temperature is 25. 25 is at here, so it's gas. So substance P is wrong. So any answer got P is wrong. Understand? Substance Q. Substance Q is negative 20 and 97. Okay. So solid, liquid, and gas. So room temperature is 25. So 25 is in the middle of negative 20 and 97, right? So you are liquid. So substance Q, it is a liquid. So many students, when they say substance Q, they were so happy and circle the answer. Not yet lah. Not yet. You need to counter check other thing. You need to counter check other answers as well. You need to counter check find other answer as well. Okay, so let's do it. So substance are melting point 35, boiling point 147. So solid, liquid, and gas. So room temperature is 25. 25 is lesser than 35. You are here, solid. So this is not what we want, right? Substance S, melting point is 5, boiling point is 120. You are solid, liquid, and gas. So we are looking for room temperature. Room temperature is 25. 25 is in the middle of 5 and 120. So it is a liquid. So substance S also a liquid. So Q and S. So the best answer is C. So I can see quite a number of you here answer A, which is not true. So please don't be so excited when you check the first answer directly circle. Please check all of them. Please check all of them. This is a careless mistake that you can improve on it. This is a careless mistake that you all should avoid. For those of you who answered A just now. Okay, I hope you all know why the final answer is supposed to be C. That's all. Okay, all right. So with that being said, we are all done for today's lesson. So guys, let me know in the chat box, how's everything for your first lesson of your Form 4? How's everything so far for your first lesson of your Form 4 with me? How's everything? How's everything for your first lesson in your Form 4 chemistry with me? How's everything? So I hope you all can see that it's not hard, right? If you really learn chemistry in the right way, you will be fine, isn't it? You will be fine. So what we do is that we learn the theory. After the theory, we directly do exercises. So you know exactly how to apply whatever thing you learn in the question. That is how we learn in a very effective way. Yeah? So again, if you have anything not sure, you need help, please, I am here to help you. Just ask. Just ask for help. I am more than happy to help you. Yeah? All right, guys. With that being said, we are all done for today's lesson. All right. Thank you so much to stay until the late night. And good night, everyone. I'll see you guys again in the next lesson. Goodbye.